This is an introductory video for using Amicus to make predictions. It covers all of the steps from entering input data to choosing models and interpreting results. The topics presented will make more sense to you if you've already watched the Amicus layout video or have spent some time familiarizing yourself with the program. In this video, I'm using the 0.5 beta version of Amicus released in December 2016. Now, before undertaking any data entry or prediction tasks, there are some good practice habits to get into when using Amicus. Firstly, start saving a session early and select a meaningful name for the prediction. This is a particularly good habit when you're making a prediction that is an update of a previous prediction, or when you might be making future updates. So say if you're using an updated weather forecast but previously entered site and fuel inputs already. Secondly, we should set the prediction purpose using the prediction purpose button up the top here. The default setting is wildfire, but it's good to double check this, as the setting of the button dictates which fire behaviour models are available for predictions. And finally, enter some unique notes that describe the prediction, including the times and purpose, etc. This will be useful if you want to come back to the saved file, especially if you have a number of similar prediction runs. Then it should be easy to identify the purpose and context for the prediction. The best place to add these notes is on the Location tab, where you can enter notes about the prediction, geographic coordinates for the fire location, and other relevant location information, including slope, aspect, and elevation. There are other opportunities to enter notes within the meteorology table and fuel scenarios, which I'll cover when we get to them. While we're here on the Location tab, I should point out that the slope and aspect settings entered are used to calculate the slope in the direction of wind, which is then used to modify head fire rate of spread calculations. If the slope in this table is kept at 0, the fire spread plot won't display any effects for slope on the rate of spread output plots. Now we've got the prediction set up and underway, the next bit of information that we may want to enter is our weather conditions. This is done using the meteorology panel. The meteorology panel is where you enter and store all weather-related data required for fire behaviour models. The main feature of the meteorology panel is a large input table containing a time series of the core dynamic weather variables: air temperature, relative humidity, wind speed, wind direction, and cloud cover. You can also see there are columns where you can enter details on the source of the data that you're using, and there's one for notes too. This might be something you want to use if you wanted to flag features such as a wind change or when you have made any modifications to the original data. When you load Amicus, there are some default entries in there, starting on today's date at 9 AM. But if you want to make a prediction, then you need to have real data in here, either in the form of weather forecasts for future conditions or observations for historical conditions. In this 0.5 beta version of Amicus I'm using here, to enter data into this panel, you either have to enter it manually or copy and paste it from other sources, or you can load it from a pre-saved file such as our example datasets that can be loaded by selecting File, Open Sample Files. At some stage we'll have a version of Amicus that can automatically download forecasts and observations, but there are a few different options for doing this, and it's something that we would probably have to do with an agency that wants to adopt Amicus and perhaps link it in with their own existing systems. The time periods in this table don't need to be regular, and you can automatically order them chronologically. When you paste in data from other sources, Amicus will automatically convert the cardinal wind directions to degrees. All fire behaviour predictions are made for the time series data within this table, so it's important that you get the data right. If you have a double up of a time and date entry, you get an alert to let you know, and you won't be able to get predictions for that point in time. Wind speed can be entered for 10 metres in the open or 2 metres via the wind height drop down button. If 2 metre wind is selected, a 2 to 10 metre wind conversion factor must be entered. The default is 3, but you can change this to whatever you like. Most of the time when you're using standard weather stations, you'll probably want to leave the wind height at 10 metres. The elevation for the weather data can also be entered above the table. This input is currently not activated, but it will be used to determine the difference in height elevation between the weather data and the fire in future versions of Amicus. Cloud cover can be entered in octaves or percentages using the cloud cover units drop-down button. This input is used for some fuel moisture calculations. If you don't have any information on cloud cover, it's probably safest to assume that there is no cloud. Daily information on rainfall and soil dryness is entered in the rainfall drought section beneath the table. These inputs are required for the calculation of drought factor and forest fire danger index. Drought factor can also be specified manually instead of being calculated. The last rainfall amount and the time since last rain is also required for the calculation of fuel moisture in the button grass fuel type, which is why time since last rain can also be entered in hours. Now let's have a look at the procedure for entering fuel information. This is done on the vegetation panel. The vegetation panel is organised into tabs for the four major vegetation groups: grasslands, native forest, shrubland and plantations. Underneath these are 11 different fuel types, which you can see in these drop-down menus. Each of these are associated with fuel type specific fire behaviour models, and you can get all of the details for these by clicking on the Amicus Help About Fire Models, and you get this document which contains all the relevant details of all the fire behaviour models used in Amicus, including the references. Fuel moisture predictions are embedded within Amicus fire behaviour predictions and use models contained within or recommended in the literature associated with each of these fire behaviour models, or those that have been found to perform best in specific studies. All fuel moisture models in Amicus are vapour exchange models that are primarily influenced by the current relative humidity and temperature, and are therefore not influenced by conditions such as prior drying, dew or rain. Only the model for button grass moorlands considers recent rainfall as a specific input. Some models incorporate the effects of solar radiation by considering cloud cover and time of day and year. As the different fire behaviour models use different fuel input variables, the layout of each fuel pane is different. Each fuel type input pane contains a Create Fuel Scenario button. A fuel scenario is a specific set of fuel conditions saved for making predictions in Amicus. All predictions are based on these, and if there aren't any saved fuel scenarios, then there are no outputs presented for fire behaviour. I should mention that in this demonstration version of Amicus, you can only have a limit of 5 fuel scenarios saved at one time. Another feature common to each fuel type input pane is the preview section at the bottom, which gives predictions for one point in time using the visible fuel variables as they appear, before you commit to making a fuel scenario. Flame height and maximum spotting distance predictions are only given for fuel types where there are existing models. Otherwise they're greyed out. So while we're here, we can make a few fuel scenarios. Firstly, we'll start with the continuous open fuel type, which we can select a pasture condition, grazed, and a curing level and a fuel load. Now you may be aware that fuel load isn't an input for most fire spread models. However, it is an input for all fuel types in Amicus as it's needed to calculate fire line intensity. You can specify fuel moisture content in fuel scenarios. This overrides the fuel moisture content calculated in the weather conditions at the time. However, you can only do this as a single number for all times at the moment. It's useful for looking into its effect in the preview section here, but is a limited use for looking at a range of times with different weather conditions. So let's save this scenario and make a couple of others. We can change the name here, say horse paddock, and give it a description if we like. How about a dry eucalypt forest fuel scenario? This will use the dry eucalypt model, also known as the Vesta model. There's two versions of this model, one with hazard ratings, they're the worded categories, and one with hazard scores, the numbers. So let's go with that. The score version gives more precision. It's useful when you have modelled data from a number of average field assessments for a site. So let's enter some numbers here. You need to have some bark hazard present if you want to see some spotting effect. We can stick with the defaults for the others. Let's save this scenario and make one more. The model for radiata pine plantations is the Pine Plantations Parametrics model. It's more complex than the other models as it's iterative, and as a result it can take some time to calculate, particularly when there's a long weather stream. Another feature of this fuel type is that it has default inputs for standardised stages within the plantation growth development cycle. This makes it easier for users with only basic information such as plantation age and silvicultural treatments. You can make modifications to these if you like, if you've got more information. So I'll save this scenario. You can see there's a progress bar at the bottom. This lets you know that calculations are underway. Now we've got some inputs, we can have a look at some of the outputs. Firstly, fire danger outputs. If you click on the Data tab, you can see the tabulated output of fire danger calculations, including the fire danger index and fire danger ratings for both forest and grasslands. The keyring used to calculate the GFDI is what's currently entered in the grassland panel. The drought factor used to calculate the FFDI is what's currently in the meteorology panel. The table uses the standard fire danger rating colours to show the fire danger outputs. The default fire danger rating thresholds are those used in the eastern states. To change the thresholds to those used in Western Australia or the Northern Territory, go to the Options Settings menu item or click on the Settings button beneath the main menu. When the Settings dialog appears, click on the GFDI classes and select Set Grassland Fire Danger Thresholds for Northern Territory or Western Australia. The fire danger output table contents can be copied and exported to other programs by right-clicking on the table. The Plot tab provides a graphical representation of the fire danger indices detailing the curing for grasslands and the drought factor for forests. You can slide the mouse along to look at the data for any point in time, and the plot can be saved to an image by clicking here. Now let's have a look at the fire behaviour outputs. There are two tables shown in the Data tab. The top one gives a range of outputs for flat ground conditions, and the bottom table shows rate of spread for a range of different slope conditions. The fire behaviour output table is the primary means for presenting the modelled fire behaviour in Amicus. As mentioned previously, fire behaviour is only calculated for fuel scenarios that have already been saved. You can select which of your saved fuel scenarios are displayed by clicking here. You can also click on the Edit button to make changes to these. To see the full range of available outputs in these tables, we'll have a look at the settings. Here you can see and select which outputs are displayed and the units that are used. Remember that not all outputs are available for all fuel types. I'll quickly go through the list now, but there are full explanations for all of them in the user guide, including notes on their assumptions and how they are derived. I strongly recommend that you look through this document. Firstly, the map scale factor needs some explanation. This is a feature for plotting fire spread on maps by hand and is set by measuring how long a kilometre is on the map that you are using. This allows for a direct map-specific distance of spread per hour for each weather period. It's used for converting the map distance rate of spread output to the correct units for quick plotting. Weather interval is the time period between the time of this row's weather observation and the next row's weather observation, based on the inputs in the meteorology table. Units can be in hours or minutes. FMC is the modelled fuel moisture content for that time. Units are in percent. Heading direction is the direction of the fire spread, which is the inverse of the wind direction. Units are in degrees. Rate of spread is the modelled rate of spread. Units can be in kilometres per hour, metres per hour, or metres per minute. Map distance is the converted rate of spread for plotting the fire progression map. This can either be expressed as millimetres per hour or millimetres per weather interval. Length to breadth ratio is the ratio between the length, the distance between the backing and head fire, and the breadth, the distance between the flanks of a fire. Flank rate of spread is the estimated spread distance in the direction normal to the heading direction. Units are the same as those selected for rate of spread. Flame height is the modelled height of the head fire flames. Units are in metres. Fireline intensity is the calculated intensity of the head fire. Units are either in kilowatts per metre or megawatts per metre. Maximum spotting distance is the maximum distance in front of the head fire that spot fires can be expected. Units are in metres or kilometres. Fire type is the type of fire in terms of crowning activity. This is only relevant for the radiata and maritime pine fuel types. It can either be surface fire, passive crown fire, or active crown fire. Reliable is a worded flag for the presence of reliability warnings. I'll discuss this next. The remainder of the settings are for the slope output table. Here you can select which slopes are outputted in the table, including the variable slope rate of spread, which is the one based on the user entered slope and aspect. The flat ground fire behaviour output table up top here also provides warnings on prediction reliability. These warnings are based on the bounds of the data used to construct and test the fire behaviour models. In order to provide some indication of the limits of performance on any particular model, Amicus colours the output cells according to the values of the output variables in the scope of the model. There are 3 different colouring schemes. So the normal is just the black text on a white background, and this shows when predictions are reliable. Here, all the values and model functions are within the design tolerances. Orange striping shows that there are some input variables or model functions that are just outside of design tolerances. And red striping shows when some input variables or model functions are well outside of design tolerances. You can hover the cursor over the highlighted cells to get a warning about the nature of the breach of reliability. The slope output table is designed to show the impact of slope on rates of spread. The slope table can show the rate of spread for flat ground, selected slopes between minus and plus 30 degrees, and user-entered slopes on the location tab. As with the flat ground output table, all of the items in the slope output table can be selected to be visible or not. All of the slopes in this table are affected by the aspect provided in the location panel. The contents of these tables can be copied or exported with a right click, like the fire danger output table. The plot tab provides a graphical representation of the rate of spread predictions. Fuel scenarios can be easily compared and contrasted for the same weather inputs. The plot for the selected fuel scenario is represented by the thickest line. Fuel scenarios can be removed from the plot by deselecting the Show Plot checkbox in the Fuel Scenario Manager. Plot images can be saved by clicking on the Save to Image button on the bottom right corner, as for the fire danger plot. Slope is presented as a dashed line in the fire behaviour output plots. These are similar in colour to the non-slope affected fuel scenarios in the plot. The slope and aspect used are displayed in the top of these plots, along with the legend for the different fuel scenario fuel types. Alright then, that's about all you need to know to use Amicus for making predictions. Remember, the fire behaviour output tables are the main means for presenting the prediction results. These tables will help you prepare prediction products, including hand-plotted fire progression maps. The plots will give you a quick visual for how conditions are changing over the course of time. Now, it's important to keep in mind that although Amicus uses the best available models for predicting fire behaviour, there will always be some uncertainty within the results because of the uncertainty in the inputs and the suitability for models to the exact application. When using any fire behaviour prediction system, you're going to have these problems, and you're going to have to make assumptions and compromises regarding the input data and the selection of your models. You'll also have to apply your judgment to the interpretation of the prediction results and how they apply in the real world. If there's anything you want to look at in more detail, you can click on the Help drop-down menu and then select Help to get the user guide, or alternatively just press F1. If you have any further questions or suggestions, put them in an email to us at amicus@csro.au.